So we have important features in electrical here. We have this switch, and what we see is a very important feature about this switch. It is a three-way switch. As you can see, doesn't have the indication for on or off. So we have we also have this switch, which may look similar, but it is not. You can see that this is on, and on the down position it is off. Okay, so it is completely different from what we have here. Okay, so this is a three-way, doesn't have the on or on, because at one point you'll find that it may be on at this point or off at this point. Okay, and vice versa. So if it is a three-way switch, it means that there is also another switch which will be working together with it, like say this one. So if we have this switch at this point and we have it another point here operating one light, or let's say two lighting points, you can find that when they are on this position the lights are on, okay, or the bulb is on. Then when you switch one on that position the bulb is off. Okay, and vice versa for the bulbs, for the lighting switch is actually served by these switches. Okay, so this is another three-way switch. If you use it alternately with this switch, that is exactly what you get in a circuit. You're going to get to that in a moment, where we'll also be talking about how to wire them. There's a video that I have done, an explainer video, where I covered these connection that you see on my table here. Okay, so briefly to explain it, what we have is the source coming from this point. So this being our source, we have the neutral coming all the way to the lighting points, as you can see distributed, and then we have the ground wire. The ground wire is also serving the lighting points, that point. So Eta says, good stuff, man. Thank you so much. I really do appreciate. So this is the incoming, the feed. So we have the neutral going direct to the lighting points, but that is not how it's supposed to be. It's supposed to get to the switch. This is just a demo, bear with me. Then we have the ground wire for protection purposes, goes all the way. And then to demonstrate our three-way switch, we have one connection that is coming from the lighting points there, that is a hot wire, and it gets to the switch, first switch, which is a three-way. And then we have these two important lines. What is the name given to these lines, my top boss? Let us engage kindly. What is that name given to these lines here? They're normally interconnected between these switches. Okay, so if you have this three-way switch at this point and you have this other three-way switch, this is basically what it means. Okay, so basically we have three-way switch one. Yeah, you have another three-way switch, and between them we link them this way. So for this, if I can demonstrate it with I have here, let me just get another switch. So we have the connection at this point where we have this two golden screws to this point, and then the common. So the common is where we feed this line from lighting points. So if this is the point that we have decided to connect, the switch that we've decided to feed the lighting points, we will definitely connect here. And then for these two, as you can see, these two link those two switches. Okay, so one screw will be connected at this point, the other screw will be connected at this point, and as they travel, they are connected to this other switch, and that is why we give them the name travelers. Is it the case really? If I might get rid of these screws. Thank you so much for joining. Thank you so much for the likes. I really do appreciate, means a lot to me. Where are you streaming me from? So these are basically two three-way switches. You can see very clean, looking great. This is another three-way switch. Okay, so basically what we are talking about is these travelers right here. So the travelers, the color code for travelers is usually black and red. So if you have a cable, like let's say uh, the Romex wire, which is 14.3, can have the black and also the red. And basically what we'll be trying to do is to link the two screws, these and these, this one as well as this one, with these two travelers, right? And then for the common, we'll have, if this switch is served by the power that is incoming, this other one will definitely feed the bulb, right? So, or the lighting points basically. So from here to the lighting points. Okay. Gilda Pablo says hello. Hello to Gilda. Thank you so much for joining. If you're interested in this topic, smash that like button. Are you interested in me lighting up that bulb with this presentation that I have on the board? Can do that so that I can basically demonstrate. So if at all it is on at this point, you can definitely connect it to power. And let me just get the cable. So if someone was to ask you what is the main difference between an electrical outlet and a switch, what would be your answer? The main difference. Yeah. Gilda Pablo is asking, what's your name? My name is John. John is my name. Gilda, where are you from? Where are you watching me from? So if we activate it at this point, you see that our bulb is lighting up. Just that it's not that tight. It's just that way. And then to turn it off, simply do that, isn't it? Then if you want to turn it on from this switch, simply do that. So you can see that the switches can be operated interchangeably like that. Okay. So if we are to switch off this bulb from this switch at this point, we simply turn it off. And you see, you can't turn it off halfway because the switch, it is either you switch it off or on, right? It's either off or on. You cannot switch it halfway. So I'm saying that because you see, with our demo, you have the chance to take the wire until that point. But with the switch, you can't like the way we were doing as kids. I don't know whether you tried it, having it at the middle point. It was so difficult. So with the switch, it is either on that position, okay? And remember, there is the difference between a single pole switch and a three-way switch. So this one is a single pole switch that we are using, okay? So kindly, if you like the videos that I put, the content that I put, subscribe to my channel, and I'll be very, very grateful. I want to thank you so much for tuning in to our today's live show. So this is a single pole switch, very different, but not really from a three-way switch. We see that there's a difference in terms of the connections and also the operation, if I'm not wrong. So what we see here is this is basically with three main connections, right? So we have the common, and then we also have other hot wire that goes to the bulb. Okay, so the common is here, then the other connection that goes to the light is here. But very important, we notice that our switch has the ground connection. Yeah, has the ground connection at this point here, and that is where we connect it. It has the same similarity with this three-way switch where we have the hot wire, and also we have the hot that goes to interlink the other switch where we connect our travelers at this point. Okay, so how will you tell using a multimeter that these switches are actually working? Okay, so can we determine using a multimeter? First, can determine whether the switch is working, number one. Number two, can determine whether indeed this is a three-way switch and whether it is working. When it is switched on this position, we expect to get a continuity between the hot line and one of these traveler points or connections. Okay, when it is in the off position, we also expect a continuity between the hot screw and one of them. All right, for this one, we will only get a continuity when it is on that position. And that continuity we will be testing between these two screws using a multimeter. If we get continuity at the on position, the switch is okay, right? Once it is off, we will not get a continuity. But if we don't get a continuity in the on position, there's a problem with the switch. Let's go ahead and do that. Right. Sorry about that. So let me first of all deactivate the circuit for safety reasons. So this being a single pole switch, we want to test using a multimeter. Test using our multimeter to troubleshoot whether the switch is okay, switch is working. So we turn the multimeter on. We're able to see that, all right. And then for us to test for continuity, find that once you bring the probes closer in contact together, there will be a sound as well as zeros on the screen. Don't know whether you can hear the sound, but at least you can see the zeros on the screen. So what does that really mean? It actually means that there is a connection. It moves from 1, which is infinity, to zeros, meaning that there is no barrier, or if there is barrier, it is negligible. that is the resistance of the probes or the wires, right? So for us to determine whether this switch is working, we'll put it at the off position, right? So the off position is that, and then we test between this screw and then this screw. So when it is off, we get a 1 on the meter, or there is no change on the digital multimeter, right? So let me just come closer. So at this point, we expect that in the off position, the circuit is discontinued. So when we place our probes like that, this, we get a 1. There is no continuity. There is no contact. All right. What's more important, when we place the probes between either and the ground, we also should not get any continuity. Why? Because the ground is supposed to protect against any leakages. So if at all there is any leakages, they will be redirected through the ground wire all the way to the electrical panel and to the ground. And that is why we always have the ground wire wired all the way to the switches for safety purposes, so that it can be connected to the switch. Okay. Now that we have already recorded that, let us switch it on. What do we expect? We expect continuity between screws. So that means that upon connection to the circuit, means that there is continuity and the bulb will receive the current flow and be able to light. So you can see on our meter it is 0, and that definitely indicates continuity. At that position, if we switch it off, find that the circuit is off. Switch it on, there's continuity. All right. The same thing happens because it is in the on position. There is no continuity still between either of the screws and the ground. And that is another safety measure to ensure that everything is safe. Because if we have a continuity or a connection between the hot wire or the line and the ground, it means that there is a problem, right? That is straight away a short circuit, right? So that is that. Now, when we get to testing these three-way switch, very important for us to note is that at one point in time, when this switch is in this upper position, we will have a continuity between the hot screw and one of the hot screws that is connected to the travelers linking the other switches, right? So at this position, we will connect one of the probe on the hot screw and on the other screw. So this is the off position. If at all this is connected to the bulb, this is connected to travelers and this is connected to the either the incoming. You can see we have the continuity there, but we don't have the continuity to this screw. If we test the other screw, it will be continuing definitely. Shall we try? Yeah, that is what we have on this hot screw right here and this hot screw right here. So that basically means if we've connected the hot wire from the source to this point, and then this is a switch is on this position, the bulb will definitely be on. And then once it is turned that way, and then you place your probe on that position, that is how it switches. Okay. So on the down position, there is continuity. And on the up position, there is no continuity, meaning infinity. but on this other side it is switching, there is continuity. So that is how you basically differentiate. All right, so those are some of the differences between the single pole and the three pole. When we talk about an electrical outlet such as this one, we have very important features as well, right? So basically we have 4 screws, fact 5. We have the ground, and then we have the neutral, and we also have the line or the hot. Okay, able to see that clearly. So this is the hot, and then we also have the neutral here. So as indicated, we have white here, and then we have black. So we definitely connect the black here. Black is definitely the line or the hot wire. Now if we use our multimeter to test, we discover that there is continuity between these two screws like that, but there is no continuity on the opposite side. Why? Because the neutral and the line are supposed to feed this electrical outlet at this point and at this point. Okay, so if there were continuity, it means that the socket has an internal short circuit. All right, so if you connect, it will create the shortest route to short the circuit. So it has to be open at these two screws. All right, so that is why we are getting one. Why we have the continuity and why we have the two screws is so that if you want to link or connect another screw from this point, you can simply tap it at this point without necessarily interfering the connection. So this is what I mean. So we have this wire here. We may just cut it and then strip it. I'm using this stripping tool. And so if just this is just to demonstrate, if let's say we were to connect at this point, so we will do it like that and just bend all the way, and there we have our perfect screw connection right there for the cable. Okay, and using our screwdriver, we'll simply tighten it. There we have it. So assuming that this is the feed, assuming that this is from the wall feeding and we want to connect another electrical outlet, let's say we have this, it is very simple. We will have to tap from this point here, and assuming that this electrical outlet is already connected, there's no point of disconnecting it at this point or adding another wire, hot wire here, and the neutral on the other side, because it will appear clumsy and even a loose connection may be formed. So we'll simply connect a wire from this screw and to this screw here, right? and that is how these sockets will be linked that way in the circuit. All right, so let us go ahead and connect it. So again, for these, we'll definitely unscrew the upper screw. Okay, so this is a 15 ampere socket. Screw at that point, unscrew simply. And take the other wire. So this, sorry about that. So you take this other wire, okay, I realized that mistake with the other one. So it's simply like that. To return it, all that we have to do is to screw it back. To make sure it is tight, it's time now to connect to the other screw, or basically feed. Not to the other screw, I mean to the other electrical outlet. So we strip without damaging the cables. And so if this is the initial outlet that we had, and we are connecting to this one, so we will make use of this screw right here with this electrical outlet. All right, so we just tighten it, and there we have it. So we will have power supply to this electrical outlet, and from this screw below, supplying to this other one. If we want to connect another socket, we simply repeat the same process. The same happens with the wire here. For the neutral connection, we loop all the way the same as the ground connection. All right. So that is it for our today's topic. I wanted us to understand a few things about electrical switches as well as electrical outlets, power outlets, and that is exactly what we have done. We have seen the connection for that, and we have also talked about three-way switch, how to tell whether they are working using a digital multimeter, and we have also seen how the connection is done for the electrical outlet. Right, thank you so much for watching this video. Subscribe to my channel, and also give this video a thumbs up if there is a thing or two that you have gained. My name is John Gatehi, and this is Top Boss Electricals. Goodbye for now.